SMPTE color bars. Usage. In a SMPTE color bar image, the top two-thirds of the television picture contains 7 vertical bars of 75% intensity. In order from left to right, the colors are white, yellow, cyan, green, magenta, red, and blue. This sequence runs through all 7 possible combinations that use at least one of the 3 basic color components of green, red, and blue, with blue cycling on and off between every bar, red cycling on and off every 2 bars, and green on for the leftmost 4 bars and off for the rightmost 3. Because green contributes the largest share of luminance, followed by red, then blue, this sequence of bars thus appears on a waveform monitor in luminance mode as a downward staircase from left to right. The graticule of a vector scope is etched with boxes showing the permissible regions where the traces from these 7 bars are supposed to fall if the signal is properly adjusted. Below the main set of 7 bars is a strip of blue, magenta, cyan, and white castellations. When a television receiver is set to filter out all colors except for blue, these castellations, combined with the main set of color bars, are used to properly adjust the color controls. They appear as 4 solid blue bars, with no visible distinction between the bars and the castellations if the color controls are properly adjusted. The bottom section contains a square of 100% intensity white and a rectangle of 7.5% intensity black for use in setting the luminance range. More modern versions of the pattern feature a plug pulse. The white square lines up so that it is below the yellow and cyan bars. On a waveform monitor, this will show up with the white bar overlapping the peak of the yellow and cyan chroma at 100 IRE units. The plug short for picture lineup generation equipment pulse is positioned within the black rectangle. Below the red bar it is present in the illustration but may be hard to see. It comprises 3 small vertical bars, a rightmost one with intensity 4% above black level 11.5 IRE, a middle one with intensity exactly equal to black 7.5 IRE, and a leftmost one with intensity 4% below black super black or blacker than black. The plug pulse aids in adjusting the bottom of the luminance range to avoid either washing out the black tones into grays or collapsing picture information into the signal clipping that occurs a small distance below the black level known as Q. When a monitor is properly adjusted, the rightmost plug bar should be just barely visible, while the left 2 should appear indistinguishable from each other and completely black. Also in the bottom section are 2 sections that contain in phase and plus quadrature signals CYIQ, centered on black level and having the same gain as the color burst signal. These show up on the pattern as a square of very dark blue and a square of very dark purple. On a vector scope, they appear as 2 short lines 90 degrees apart. These are used to ensure that the television receiver is properly demodulating the 3.58 MHz color superior portion of the signal. The vectors for the I and plus Q blocks should fall exactly on the I and Q axis on the vector scope if the chrominance signal is demodulated properly. These bars give rise to the former portion of the casual term bars in tone. Typically, a television network, TV station, or other originator of video programming transmits SMPTE color bars together with a continuous 1000 Hz audio tone before sending program material in order to assert ownership of the transmission line or medium, and so that receiving stations and intermediary telecommunications providers may adjust their. Likewise, producers of television programs typically record bars and tone at the beginning of a videotape or other recording medium so that the playback equipment can be calibrated. Often, the name or call sign of the TV station, other information such as a real-time clock, or another signal source is graphically superimposed over the bars. An alternate form of color bars is the 100% color bars pattern specified in ITUR Rec BT 1729, or RGB pattern, sometimes called full field bars, which consists of 8 vertical bars of 100% intensity and does not include the castellation or luminance patterns. Like the SMPTE standard 75% pattern, the color order is white, yellow, cyan, green, magenta, red, and blue, but with an additional column of saturated black. This pattern is used to check peak color levels and color saturation as well as color alignment. The 100% pattern is not as common or as useful as the SMPTE standard 75% pattern, but many pieces of test equipment generate both patterns and can be selected to generate either one. Many professional cameras can be set to generate a 100% pattern for calibration to broadcast or recording equipment, especially in a multi-camera installation where all camera signals must match. There is another 75% pattern that consists of the same 8 columns as the 100% pattern, but at 75% intensity. This pattern is very seldom used. Although color bars were originally designed to calibrate analog NTSC equipment, they remain widely used within modern digital television facilities. Color bars are used to maintain accurate chroma and luminance levels in CRT, LCD, plasma, and other video displays, as well as duplication, television, and webcast equipment. YIP-PR and YIP-CR values of 75% 100/0/75/0 SMPTE color bars 0.75 asterisk 219 plus 16 equals 100. The values of 100% 100/0/100/0 SMPTE color bars 1.0 asterisk 219 plus 16 equals 235 using BT 709-2 matrix coefficients. Only white and black are the same using BT 601 matrix. The two are rec. BT 1729 specified the last two 100% colors, green and magenta. It also specified all 100% colors for BT 601 matrix, not only BT 709.